Welcome to this video. We'll be dealing with the coefficient of variation. Remember this, there is the arithmetic mean, so a measure of central tendency, and then there's a measure of dispersion telling us how much the values are distributed to the right and to the left. And the thing is, the standard deviation tells us they are distributed to the right, some part to the right and some part to the left with a symmetric distribution. Let there be two normally distributed values, so the black one and the red one. With the black one, there is the average value, there is an arithmetic mean of 5 and a standard deviation of 0.5. And remember this, once you understand the normal distribution, you see that the normal distribution depends on two values only, on the mean value and on the variance or the standard deviation, which are not the same, but once you get the variance, you just take the square root and you have the standard deviation. So it's on two values only. And those two values are the center, 5, and then there is one time to this value, to this point, the point of inflection, as we say in mathematics, and this is once the standard deviation. So from 5.5 to 4.5, or the other way around, from 4.5 to 5.5, it's a certain area in which there are approximately 68% of all values. Now, the black one is dependent on those two values. The red one, the red distribution, has an arithmetic mean of 10 and a standard deviation which is in the value, in its total value, is equal 0.5. So we could say that the measure of dispersion, since it's the same, there is an equally distributed change or dispersion, which is somehow true, but since those measures of dispersion actually look at the mean value, it's not true at all. So the coefficient of variation tells us, with regard to the average value, what is the standard deviation with regard to this average value. Now, as we need to compare those coefficients of variation, the black one, coefficient of variation, which is defined as the standard deviation, so 0.5, divided by the average value, divided by 5, is equal to 10%, isn't it? To 0.1. The red one, so the relative, I wouldn't call it the relative standard deviation, but the relative measure of dispersion is equal to 0.5. So in absolute terms it's the same, but in relative ones it's not, since 0.5 divided by 10 is equal to 0.05, as I would say, not making use of a handheld computer, but it's easy, of course. Now, the relative dispersion with the black distribution is twice as much as the relative dispersion of the red distribution, and therefore it's much more distributed. It's much more dispersed. I'm sorry. It's much more dispersed, the black one, than the right one, the red one, is. Thank you for watching.